Hi, let's demystify coordinate geometry. Now, to be able to solve questions from coordinate geometry, you should have a full grasp of these concepts here. The distance between 2 points, the midpoint of a line, the gradient of a line, and the rest of them. Now, let's get right to it. Now, what is coordinate? Coordinate refers to a pair of numbers that describes the position of a point on a Cartesian plane. Okay, a pair of numbers that describes the position of a point on a Cartesian plane. Now, this is what the Cartesian plane looks like. So let's call this y-axis and this x-axis. So if I count the units from here, 1, 2, 3, 4. So let me call this 4. And then I count 1, 2, 3, 4, 5. Let me call this point 5. Now, if I pick a point here, this point will be described by these two numbers, which I can write as 4, 5. Okay, so if I call this point point A, then the coordinates of point A will be 4, 5. Okay, now this value here, this value 4 is usually referred to as, that's the value from the x-axis is usually referred to as the abscissa. And then this one is usually referred to as the ordinate. And together they are called coordinate. Okay, so that's basically the idea behind coordinate geometry. Now, the first concept we're going to look at is distance between 2 points. So let's get to it. Now, to to get the distance between 2 points, you would need a formula, okay, or say an equation, okay, and I'll try to derive that equation or that formula right now. So let's derive the formula that would help us calculate the distance between 2 points on a Cartesian plane. So let's say we have our y-axis and x-axis, and then I'll pick 2 points. Let's say we have this point here, and let's say we have another point here. 2 points. Okay, now let's say the coordinates of this point is, let's call the value on the x-axis as x1, and here on the y-axis as y1. Okay, so that would mean that the coordinates of this point, let's call it point A, would be x1, y1. Okay, and then let's call this point B, and then let's describe the coordinate as let's call this point x2, and then this point on the y-axis as the ordinate, let's call it y2. And so the coordinate of point B would be x2, y2. Now we're interested in the distance between them, so let me link them up. So I have this length is what we're interested in, that's the distance, which is the same as the length of the line that connects them. So the distance from here to here. Now I'm going to also connect this point from here to here, so that I would have a right angle triangle. So this becomes a right angle triangle where AB is a hypotenuse. Okay, so we're interested in the hypotenuse. Now, if this is a right angle triangle and we want to get this length, of course, we know we just apply the Pythagoras theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, we need to know the other two sides. So from here to here, from A to C is x1 to x2. So the distance between them will be x2 minus x1. And then from here to here, we have y2, y1. So the distance between them will be y2 minus y1. Okay, now applying Pythagoras theorem, the square of the hypotenuse will be AB squared will be equal to the sum of the squares of the other two sides. So we have AC, which is x2 minus x1 all squared. So I'll write x2 minus x1 all squared plus this side BC, which is y2 minus y1 all squared. Now we're interested in AB and not AB squared. So I'll take the square root of both sides. So if I take the square root of this side, it takes the square off. So I'll be left with AB equal to, and then I'll take the square root of this side also. So, and I'll have x2 minus x1 all squared plus y2 minus y1 all squared. So this formula helps you find the distance between point A and point B. So that's what we call the distance between 2 points. So once you know the coordinates of the 2 points, you just slot in the values here and you have the distance between 2 points. Okay, so that's it. So let's quickly take a few examples, maybe 2 examples. Let's look at the first one from a past question. So this is from UTME 2008. It says calculate the distance between points L minus 1, 6 and M minus 3, 5. Okay, so now you know the formula for the distance between 2 points. So the points are L and M, so we use L and M in this case. So LM, which is what we're looking for, LM will be equal to the square root of, remember the formula, x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so now this is what we need to find the distance between L and M. Okay, now what you do now is you go to the points that are given. This should be your first point, point 1, and this should be your point 2. Okay, now do well to always label your point 1 x1, x1, sorry about that, x1, y1, and then your point 2, x2, y2. Okay, now this would help you not to mix up the values because sometimes it can be confusing. So now you go straight and slot them into the formula. So your x2 you can see is minus 3, so you have minus 3 minus x1 is minus 1, so I'm going to put the minus 1 in a smaller bracket, minus 1. Okay, and then I'll close it up, all squared, plus y2 is minus 5 minus y1 is minus 6. So I'll put that 2 in the bracket, minus 6, and then close it up, all squared. Okay, let me extend this. All right, so now we'd have this will be equal to minus 3 minus minus 1. Minus times minus becomes plus, so we'll be left with minus 3 plus 1 all squared plus the same thing here, minus 5 minus minus 6 becomes minus 5 plus 6 all squared. Okay, and this will be equal to the square root of, now we have minus 3 plus 1 is minus 2. So I have minus 2 squared plus minus 5 plus 6 is 1. So I have that. Okay, I'll take this right up here, and this will now be equal to the square root of minus 2 squared is 4 plus 1 square, of course, is 1. So it means that, therefore, the length or the distance between the points L and M will be equal to the square root of 5. Now, we usually say units. Okay, so option A is the right answer for this question. Okay, now let's look at another example. Okay, look at this question. Now, this is from UTME again, 2009, for Nigerian students. It says, what is the value of R if the distance between the points 4, 2 and 1 R is 5 units? Now, if you notice, they've given you the distance between the 2 points. So in this question, you're not required to calculate the distance between 2 points, but of course you still use the same formula. So you're looking for the ordinate, that's the value for the second point. Okay, the x, rather the y value for the second point. So let's get right to it now. For just clarity, you could just label this point here point A, and this point B. Okay, and so we can just write AB, that's the distance between them, is equal to the square root of, remember the formula, x2 minus x1 all squared plus y2 minus y1 all squared. Now remember, AB has been given. Okay, in this case, that's the distance between them, these 2 points, has been given already as 3 units. Okay, so we just write 3 is equal to the square root of, now x2, remember, always label these points so you don't get them mixed up. This is the first point, so we have x1 y1, and second point x2 y2. Okay, so x2 is our x2, so that's 1 minus x1 is 4 all squared plus y2 is r, which is what we're looking for, minus y1 is 2 all squared. Okay, so let's just deal with what is under the root sign first. So we have this 1 minus 4 is minus 3 all squared, and then we're just going to leave this like this, r minus 2 all squared. Okay, and then our 3 is equal to the square root of, now minus 3 squared is 9, and then we have our r minus 2 all squared. Now at this point, we'll take off the square root. Okay, we'll look for a way to take off the square root. Okay, now one common mistake students make when they get to this point is they cancel off this and this. So this, at this point, this square root cannot take off the square. Okay, because of this number here. All right, if it were just this alone, then that could work. So we need to first of all remove the whole square root by doing something else. So we remove it by taking the square of both sides. So we take the square of this side and the square of this side, so that this, will take off this now. Okay, I'll take it off from here. And so we have 3 squared, which will be 9, will now be equal to, we're left with just 9 plus r minus 2 all squared. And then I'll take 9 over. I'll have 9 minus 9 will be equal to r minus 2 all squared. Okay, of course 9 minus 9 is 0, and it's equal to r minus 2 all squared. Now to remove the square here, we'll take the square root of both sides again. So if I take the square root of this, remember the square root of this will take off the square, and the square root of 0 is 0. So I'll just have this is equal to r minus 2. Okay, so at this point, I'll take this over. So I have 2 is equal to r, or r is equal to 2. And that is our answer. And that would be option B here. R is equal to 2.